All right, the first thing is this, what I call the breach of encapsulation. And again, all right, here I have an array instance variable, and I have setters and getters on it. So here's a getter, and here's the setter. And usually if we're dealing with primitives or even something like a string instance variable, then you can just return the variable, and that's what we're doing here. But I said that this is an encapsulation breach. Why? Because what we're returning is we're returning this array, and an array is an object. And when I have an object, I can do stuff to it. So let's let's create another. Well, let me run this first, just to remind us of what we had. So we had. Okay, we created 3 of them. Okay, we created our MyPets class, and then we said, okay, we're going to create the array that's going to consist of the animals inside that, and then we're going to do that. So let's create another one. So I should have maybe given these a name, but and what I'd like to do here is, instead of I've already kind of declared an array here, so let's just kind of use that again. So, but let's just set it to different things. So my animals here. What should we call this? Let's make this. Oh, I already gave it a monkey. Oh, let's Dumbo. Oops. And oh, what? Jerry. And was that the mouse or the cat? The mouse. Okay, makes sense. And so now your pets will set the animals, and let's print that out. And well, kind of before I do that, just to indicate this, let me. Let me just to kind of. Okay. Right. So now I have 2 instances of MyPets, and the first one had what we had, and then the second one had the new ones that we created. No problem, right? So let's take a look at MyPets again, just to kind of see. All right, do you see what happened? Okay, we started off with Fluffy, Shiny, and George. And then we created a whole other instance, and we gave it Dumbo, Jerry, and Bam Bam. And then when I print my pets again, all of a sudden, instead of Fluffy, Shiny, and George, I have Dumbo, Jerry, and Bam Bam. I see how impressed you are, but...
The arguments are different because that one's my pets and the other one's your pets.
This is my pets again. See, I printed my pets. My pets should have Fluffy, Shiny, and George. And all I did was I said, okay, I want to create another one. You know, a totally seemingly innocuous thing that I've done in creating the second one. But what I've broken encapsulation, meaning that I have changed the value of the internal state of my pets, not through one of its methods, because notice I didn't say set animals on that, but I've changed it because that reference to animals, see here, when I set it, I simply set I set it to whatever I passed in, which meant that this object, this instance variable, was pointing to exactly the same object as this one that was out here. And that's what I mean by breaking encapsulation. In other words, encapsulation is that your instance variables of a class, of an object, should only be changed by a method of that object. And here I've changed the instance variable, the state of this object, from the outside without going through one of its methods. The only way I should be able to change the value of animals is through this setter method. That's the only way I should be able to change those values. And yet I've been able to change them without doing that. All I did was I just kind of defined some new things in this array, perfectly legal, set them here, and then all of a sudden I've totally, corrupted the internal state of the other object. And that's what breaking encapsulation looks like. And this is why encapsulation is such an important thing, because I don't realize that I'm doing this. Okay, so what's the fix? Well, the fix turns out to be a very simple a simple method of all arrays. All arrays, again, they're first-class objects. They have methods. Every array has a method called clone. And so if I have an array, what clone does is clone creates a new array and just copies the values in it, as you would expect. So when you have an instance variable that's an array, on every setter and every getter, you always use clone. Now, okay, so see what happened here? Again, I started off with Fluffy, Shiny, and George. I created a new one and gave it Dumbo, Jerry, and Bam Bam. But then all of a sudden, my original one was now these new ones. And I don't want that. By changing this to clone, oops, doesn't have I got to run the main method. That's okay. So now when I run it, because when I set it, I didn't copy a reference to that array. I copied a copy of it. And now when I do the same thing, my state is maintained. Okay. Okay. So now, let's see, what was the next thing I was going to do? Oh, yeah, the next thing is, this may seem a little odd. Okay, so I'm going to create another one. Let's say my, and if you see these logger things, that's, again, that's just something that I use when I'm actually developing. All right, so what I want to do now is just kind of work. You've done nested loops in other places, have you, or have you? Yes, no, some, yes, okay, so, but we're gonna do it here, and, the thing is here, is that, okay, I wanna create 20 of these, but, what I want to do is I'm gonna have, two arrays of strings. First, I'm gonna have the types. I'm going to have 4 types of, oops, not string. Oh, and let's make it sort of simple. So what are, okay, so I've created an array of the different types I want to have. And I'm going to create an array of, oh, let's make it length 5, of the different names that I'm going to be using. So I can reuse some of these. No. Somebody give me a name. All right. And so what I want to do is I'm going to create an array of these pets with every combination of types and names as in one array. You said that this is where the arithmetic kind of comes in a little bit. So let's okay. So here's how we do it. So we have an outer for loop. Let's iterate through the types. Again, yeah. Now notice the principle for iterating through arrays is always use the fact that the array knows how big it is. Because for some reason, in some programming languages, the arrays don't know how big they are, and so you have to have another variable that says how big it is. And Murphy's law says when you're trying to keep the same information in 2 places, that it's going to get out of sync. In other words, if I have a separate integer that says this is how big my array is, at some point I'm going to change the size of the array, but forget to say change the other int. Here, even if I change the size of these arrays, this will always work. I don't have to worry about that. Okay. All right, so now what I want to do is I want to, I mean, have you ever done this exercise? Where I'm unraveling, I have 2 indices that are kind of going up, but I want to unravel, I want to kind of flatten the whole thing, right? So how do I do that? Well, okay, so the way I do that is okay, so names names J, sorry, and then types I. Okay, so I think this is right. I didn't write it down, so I'm kind of doing it from memory. All right, so what the trick is that, and this is a place where the zero-based indexing actually kind of is a little bit helpful, is that on the inner one, J is going to kind of keep spinning up, but then as I goes through 0, 1, 2, etc., then this will kind of advance it to the next row, as it were. Okay, does that make sense? I think it makes sense. I think I've done this right. I may not have, but since we can set our animals to this and then print them out. Oops. Okay, so this seemed to work. Actually, just to be sort of clear, let me do this. Well, no, I can't do that. Okay, so well, let's just sort of check. So we have Fluffy Dumbo. He goes through the names for the dog, and then goes through the same names for the cat, etc. Okay. So that's just a way of kind of taking two arrays and flattening it out to one array, and the key thing is this little expression in here. Okay, so I mean have you done something like this before? Or if you haven't, then now you have. And okay, now I'm going to do something that, now notice the NetBeans has this little tooltip here where it says on branch master in sync with upstream branch but it says it contains added and modified files. So if you want to see what I've changed, if I right click on the project, say git show changes, and it shows my pets has been modified, that's when I added the clone. Test my pets, that's when I added the encapsulation breach problem. And then test my pets 2, which is the new one, that's in green. So blue means changed, green means added. And in a way, I've kind of reached a stopping point, or at least a resting point. And so what I'm going to do is I'm going to commit this. So committing is like voting in Chicago. You should do it early and often. Okay, and then just have a little, so the encapsulation, we fixed it, and then also the nested loop. All right, and when that's that's committed to my machine right here. Now, time permitting, I'll kind of show you, if not today, then tomorrow, how you can, everything I'm doing here, you have access to. Remember, if you look on your GitLab page, you see my CS2173, and so what you can do is you can clone that yourself and just pull down everything I'm doing here once I've pushed it up there. Okay, but what I want to do is I want to come back to this to my pets. Okay, and actually here, see in my comments, I said it actually breaks encapsulation, but it doesn't anymore. So let's sort of fix that. Get and then set. That was just a reminder to make sure to fix it. And in fact, the comment should be something like a copy. All right, so what I'm going to add now is, notice that this array has things in a particular order, and for whatever reason, I decided I want to kind of mix things up. I want to just shuffle them randomly. Now, how do I do that? Well, I do that using a I like to call these RNGs, but Okay, so random is a built-in Java class. And okay, here I try to use it and it says it can't find the symbol. So this is our red squiggly. But again, remember I said that whenever you see a little light bulb with a red dot on it, hover on that. In fact, if we click on that, it gives you some suggestions. It says, okay, I can't find this random class, and it gives you 3 options. I can create a class here, I can create a class somewhere else, or in this case, I can add an import, and that's what I want. So when I add the import, and I'll talk later about what import does. Actually, import is very badly named because it actually doesn't import anything, but that's what they call it. And then notice the red squiggly has gone away. Now at this point, remember what the default value of an object is? If I don't instantiate, if I declare a variable to be of type an object type, but I don't instantiate it, what is its value? Null. And if I try to use that before I've instantiated, I will get something called a null pointer exception. In fact, that you will, as you start working, you will get many, many null pointer exceptions, promise. And that's actually a good exception because there's only one thing that causes it, an object that's null. Okay, so how do we fix that? We simply instantiate it. And in this, notice I'm instantiating it in the constructor. Again, in JavaScript, you had there is kind of a notion of constructors. So when you create a new one, there's stuff that you do in the constructor that you always want to make sure happens. Here, for example, we wanted to make sure that this pet array was always at least something. So, but we didn't know what could be in it, so we just kind of set it to a 0 array. Here we're going to do this to it. All right, so what I want to do is I'm going to use this random object to, I want to shuffle the order of these, of this array. And how do I do that? So I'm going to create a method called shuffle. And here's basically the strategy. What I'm going to do is I'm going to step through the array, and at every point in the array, for each element of the array, I'm going to choose another random element of the array, and I'm going to swap them. So once I do that, they'll be in a different order. Now, have you done something like that before? Maybe? No? Yes, you have. You're the only one, or? Pardon me? Oh, okay. Oh, they had a card thing in Python?
Well, yes, somewhat. Set a list of strings, and then we shuffle the string.
Ah. Okay, so this should be familiar to you, sort of. Yeah, no, actually, because...
Let's not oversell this.
Okay, yeah. Yeah, because we're going, actually, the first thing I'm going to have you do is a card thing as well. I guess that's a popular thing. But we're using card objects.
Yeah, we did not.
So, okay, so, all right, but here, all right, so we have this array of pets there, and so how, okay, so we iterate through, I call them animals. All right, now, okay, so what I'm going to do is I'm going to set this equal to, okay, so first I say, all right, I'm going to step through and I'm going to touch every single one. So first I'm going to say, okay, here's the one that I'm touching right now. And now I'm going to get my random index, and RNG has a number of methods, but I'm going to get my next int from this. And what this does is the next int, and if I give it a value here, it will generate a random number between 0 and 1 minus this. So that you've seen something like this in JavaScript, no doubt? Okay, yeah, so, all right, so I'm gonna swap this index with this index. And so I'm gonna set this equal to that, okay? See, so I've saved the old one. Now I've clobbered the one I'm pointing at, and I've put in its place the one at swap index, and so I need to put swap index back to that. Okay, so every time I call this, it's going to just basically put them in a different order. So let's, where is it? Okay, yeah, here. All right, so, all right, remember we had this, so let's shuffle them. So here's how I do it. No, just pets. Okay. Now notice something, that when I hit the, you maybe notice this, is when I hit the dot, what it does is it gives me a list of all the possible methods I could invoke on that. And what's really cool about that is that it keeps me from fat fingering. All right, and so if I print that, okay, so first it kind of went in order. First all the animals, types, and then the names, and then now it's all mixed up. Okay, so it's accomplished that, and it's accomplished that by, and there are lots of different ways of doing it. This is perhaps a naive way, but it's one that works, and it's basically order n, because you make one pass through, and in a way, if you're shuffling things, you probably can't do much better than order n, because you have to at least switch every single one. Okay, so again, to recap, we've kind of reviewed the operators, and